Hey! I hope you've come here from the adding vectors graphically video because that is a sad place for me. It was a rougher time. We want to add vectors that are normal to each other. This is pronounced normal because that's the first definition of the English word normal. There's a P word, but I don't want you to use the P word in this case right here. These vectors are normal to each other. Okay, so I made some steps to add vectors that are normal to each other. Those are not the steps. To add vectors that are normal to each other, I want you to draw a coordinate system, draw the vectors tip to tail, then draw the resultant, and the resultant starts at the beginning and goes to the last vector's tip. It represents the sum of the vectors, so it has to do everything that those vectors do also. And then step 4 is to use p-thag and inverse tangent to find out about the vector aura. So I'm gonna just jump in and do this a bunch of times, but copy this down so that you can see what I'm doing. And I'll leave it up there so that I can see what I'm doing as well. Here's the first problem. Your mom goes 17.0 meters to the west, and then she goes 2.0 meters north. And I saw her do that, so I know it's true. Here's the first step. A coordinate system needs to show west and north, and so I'm thinking I can do a standard coordinate system like this where I show north and east. And these two vectors tip to tail, well, one vector is supposed to be west, and it's supposed to be 17 meters. Now, I don't have to scale this because I'm going to use math to solve the problem for us. And there's the vector that I'll call A. This one is what I'm identifying as vector A right here. And then I'm going to call that guy vector B, so I should draw that tip to tail. Well, this vector is supposed to be pointing like that, to the north. So I could put that right here, or here, or here, or here. Think about which way, where, who, what I'd like to put it tip to tail with vector A. I think that this is probably the best place to put it. And it's a little bit shorter, so I draw it as a little bit shorter, but I'm not going to stress about rulers and all of that nonsense anymore. We're moving on. Aura now starts from the base of A and goes to the tip of B. This is our resultant aura, and we're trying to find out everything about aura. So it's going to have units of meters, blah, blah, blah meters, at what angle? Some degree, some angle, probably that angle right there, which we'll be able to find using math. Yay! And something from something. Okay, so here's what I'm thinking. We're probably going to use p-thag to find that distance right there. And I've got this side, and I like to put it all in one line, so I'm going to open up a scroot, and I'm going to put some stuff inside that scroot in parentheses. Open parentheses. 17 square. Yeah. 2 square. Yeah. And if these were negative numbers, I would still just put them in parentheses and square them, so I'd get positive numbers all the time. All right, so I find that I've got 17.1 meters is how far your mom actually was displaced. And then I need to find this angle right here, and that's an inverse tangent problem because I know that the tangent dragon is eating the theta right there, but that's opposite over adjacent. And the only way to kill a tangent dragon so that you can save the precious pearl theta is by attacking with the inverse tangent. You come in all swooping, guns blazing, you're like, inverse tangent! And inverse tangent! And then, well, when the dust settles over here, you've just got a drippy old theta. It's like oozing dragon goo, and on the left side, well, the left side's just theta, but the right side is inverse tangent of opposite over adjacent. So you're supposed to take the inverse tangent of the opposite side, which in this case is 2 meters, over the adjacent side, which is 17 meters. Watch this. I'm going to make sure that I'm in degree mode, because, I don't know, I wrote a degree there, whatever. So I take inverse tangent of 2, which was the opposite side, divided by the adjacent side, which is, oh my goodness, 6.71 degrees. That's not a lot of degrees, and that's consistent with my picture where B is short and A is long. All right, so here's what I'm saying. This is, well, it's almost, this vector aura is almost in what direction? It looks like it's not almost north, it's not almost east, it's not almost south, it's almost to the west, but it's a little bit up from west. It's a little bit clockwise from west. It's a little bit up from west. It's a little bit north from west. All right. Cool. Next problem. A ping pong ball travels at 801 meters per second up and 301 meters per second to the north. And this gives my students great pains to do it. But perhaps you can triumph where they sometimes struggle. Or if you're one of my students, maybe you will begin to triumph in just a moment. Here we go. I'm trying to draw up, and I'm trying to draw north. My personal preference for my coordinate system is to show up right there and north right there. Okay, all right, okay. So I'm trying to add these two vectors. One of them is this way, and it's supposed to be 801. That's vector A. And the other one is supposed to be that way. It's quite a bit shorter, and that's vector B right there, and that's right there. And I'm supposed to add those guys tip to tail. Well, I can do that. I'll just put this one here and that one there. And then, well, I believe the next step is to find the resultant. And the resultant is going to start right here and go right there. And you can stop any time because these are all the same sort of problem. I need to know everything about aura. It's probably going to have units of meters per second, and it's going to be at some angle. What angle? What from what? Let's find out what's in those blanks. You want to do some Pythag? Because I'm thinking I need to be, ooh, let's look at this. I could just do that. Yeah, what fun. I'm going to type in here 801 square, and then I'm supposed to square 301. Yep, got that. Yep, gonna take the square root of that. I get 856. 856 meters per second. And this is exact. I mean, look at all the digits right there. I need to do sig fig rounding because I know too much. This is a great contrast with that that thing that we were doing, that graphical method. Ew, I hate that. Now I need to find the angle. This angle right here, this says that aura is not exactly in the up direction. So it might actually be said that we are north of up. That's a little bit hard thing to try to wrap your head around, but there it is, north of up by how many degrees? Well, let's take north from up. You see, I started looking at the up direction. That's this direction right here. And then I said, whoa, to get there, I need to go by theta to the north. So it's north from up, not up, but a little bit north from up, a little bit north of up. All right, let's take the inverse tangent of the opposite over the adjacent, which is the inverse tangent of 301 over 801. Boom, boom, 301 over 801. Enter. It says 20.6 degrees. 20.6 degrees. Interesting side note, sorry if I'm boring you, we could do this one and then this one, and then the resultant would look a little bit different. Wait a second, the resultant would look exactly the same. This resultant, though, would be a different angle. That angle is called the complement, because in this case, it would not be 20.6. Let's see how fast Dr. Schuster can do math in his head. I think it's gonna be something like, oh my gosh. Wow, it actually turns out to be, well, it's not going to be 70, it's going to be 69.4 degrees up from north. See how these guys have switched places right here? But 69.4 and 20.6 add up to 90 degrees, and that's what it means for them to be complementary. These are both valid answers. They will be accepted by every physics teacher everywhere because we love you. Here's the third problem. A flea goes a little bit to the south and a little bit to the east. And you actually are given a problem here. You have to find the displacement of the flea, which is sort of what we have been doing. We've been adding these vectors. So I'm going to define this guy as A, and I'm going to define that guy as B. And I'm going to draw them. Well, this one's supposed to be twice as long as that one, but I need to establish a coordinate system. Here's my coordinate system. It says north and east. And I'm trying to find some vectors. So let's see, south? Okay, great. Long vector to the south, and then short vector to the east. Done. Here's A, here's B, and I'm supposed to draw aura. Aura starts right here and goes right her, and I'm trying to tell you everything about aura. It's probably blah 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 in meters at so and so degrees something from something else. All right, let's figure it out. And that's going to be that angle right there that we're trying to find. It's the angle at the base of aura that we're trying to get. Now let's do a little bit of Pythag, and this is tricky. You have to be careful with your parentheses. I'm supposed to square, watch this, I'm supposed to square 2 times 10 to the negative third. So I write 2e negative 3 close parentheses square, and then I'm supposed to add that circle to open parentheses 1e negative 3 close parentheses square close parentheses for the scroot, and I get a number. And look at that, the aura is supposed to be 2.3 2, 4 times 10 to the negative third meters. And that's nice because it's the same ballpark as these numbers. It ought to be 10 to the minus third meters. If you're not getting that, then probably you're typing something wrong into your calculator. Be careful, my dear students. And then you're supposed to take the inverse tangent of one over the other. All right, let's take, you know what? Here's a nice thing. I'm taking an inverse tangent, right? And I'm supposed to take an inverse tangent of the opposite side, which is 1.00 times 10 to the negative third meters, divided by 2.00 times 10 to the negative third meters. But look at this. Those guys cancel, and those guys cancel, and all those zeros are just stupid. So theta is all that stuff. That's just the inverse tangent of a half. Awesome. Let's do that. That's going to be easier. Tangent of 0.5. Okay, good. That's 26.6 degrees. 26.6 degrees. And am I supposed to be, well, what is this? It's not exactly to the south, right? It's a little bit to the east of the south. This is south. We're going east of south to find Ara, so I write east of south. South! That's not south. What's wrong with you? Number 4, a bag of Cheetos accelerates forward and to the left. This coordinate system is a little bit strange. I will write forward up here. It seems like it's a local coordinate system. And this guy right here I will call to the right because that's definitely not to the left. Let's do a brighter green, maybe an electric lime for this problem. I'm supposed to draw these two vectors. This guy I'm going to call A, and that guy I'm going to call B, and they're going to have to be at right angles to each other. So I first have a long vector that's forward, and then a shorter vector that's to the left. So here's vector A, and here's vector B, and the resultant, as always, is starting where the first one begins and going where the last one ends. And there's Ara right there. You found it. Now tell me everything about it. Ara is blah, 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 meters per second square at what angle from what? What from what? Let's do it. Let's do it. You want to find out what that hypotenuse is? This guy right here, the length of Ara? Well, it's simply going to be the square root of 9.81 square plus 4.88 square equals. It looks like 10.9. Ah, it's 11.1. Gotcha. Sig figs. Careful. And then I have to find this angle. This angle is, well, it's the angle away from that direction, which is forward. So this is left of forward. See that? It'd be like you turn to the left. Left from forward. Okay, that's kind of sloppy there. But I'm trying to find this angle, and I have to take the inverse tangent of the opposite side, which is B. That's opposite of, let's see, tangent inverse of 4.88 divided by 9.81. And that's going to get me theta, so let's do that math right there. The inverse tangent of 4.88 divided by 9.81 is, I get 26.4 degrees. See ya. 17.0 meters to the west, and then she goes 2.0 meters north. And I saw her do that, so I know it's true. Here's the first step. A coordinate system needs to show west and north, and so I'm thinking I can do a standard coordinate system like this where I show north and east. And these two vectors tip to tail. Well, one vector is supposed to use the P word in this case right here. These vectors are normal to each other. Okay, so I made some steps to add vectors that are normal to each other. Those are not the steps. To add vectors that are normal to each other, I want you to draw a coordinate system, draw the vectors tip to tail, then draw the resultant. And the resultant starts at the beginning and goes to the last vector's tip. It like Hey, I hope you've come here from the adding vectors graphically video because that is a sad place for me. It was a rougher time. We want to add vectors that are normal to each other. This is pronounced normal because that's the first definition of the English word normal. There's a P word, but I don't want you to use represents the sum of the vectors, so it has to do everything that those vectors do also. And then step 4 is to use Pythag and inverse tangent to find out about the vector Ara. So I'm going to just jump in and do this a bunch of times, but copy this down so that you can see what I'm doing. And I'll leave it up there so that I can see what I'm doing as well. Here's the first problem. Your mom goes to be west, and it's supposed to be 17 meters. Now, I don't have to scale this because I'm going to use math to solve the problem for us. And there's the vector that I'll call A. This one is what I'm identifying as vector A right here. And then I'm going to call that guy vector B, so I should draw that tip to tail. Well, this vector is supposed to be pointing like that, to the north. So I could put that right